brain is the seat of all human thought, sensation, and emotion. It controls everything from breathing to movement and cognition. At the Miller School of Medicine, our researchers are constantly pursuing scientific breakthroughs in the neurosciences, which are leading to amazing discoveries in the treatment of brain-related diseases and disorders. It all begins here in our laboratories. This is where researchers like Dr. Miguel Perez-Pinzon are exploring new methods in neurology to predict a patient's risk of suffering a stroke in the hopes of preventing it from happening at all.
Since I was, very young, I was interested in science. So I did my PhD in marine biology with link to neurology by studying diving species. We were looking at the brain of turtles. These species actually take a deep breath and they go underwater and they spend hours and sometimes days without trying to come back. And the brain basically switches completely. It's like hibernation. It's like having a stroke down there, but their brains don't suffer. Nature is linked, and we have found that actually humans have the capability to do it. We are trying to target these patients that could have a stroke or a heart attack, trying to modify the brain and so they become more resistant to a potential stroke or cardiac arrest. Our lab has been the pioneer in the field of prophylactic treatments. We have found a number of pharmacological agents that appear to be very powerful. And one of them is called resveratrol, which is a chemical found in red wine. Resveratrol can change your epigenome, basically your gene expression. It works beautifully in protecting against stroke or cardiac arrest. I'm absolutely committed to continuing this. This is my goal, is to basically see the therapies that we find here taken all the way to the clinic.
The advances in our laboratories are also leading to groundbreaking treatments in neurosurgery for patients with spinal cord injuries. Doctors Jonathan Jagid and Iahn Cajigas are exploring revolutionary methods to give paralyzed patients the ability to move their limbs again using only the power of thought.
I was an electrical engineer, and I had a good friend of mine become paralyzed when I was very young. During the course of my meandering in the university, I came across the ability of applying engineering techniques to helping patients and people with paralysis as a potential avenue of research. And so it was through that research in engineering that I got more and more excited about actually helping those patients on a day-to-day basis as well, and therefore decided after doing engineering to go to medical school and actually train to be a neurosurgeon so that I could firsthand work on developing the techniques that are going to allow the engineers to bring these things to real life.
The reason that I picked the subspecialty that I picked in neurosurgery is clear to me. I mean, this is an area of neurosurgery that allows you to engineer new technology and institute it in a way that produces relatively immediate results. That's what I love about what I do. It's seeing the results in real time.
The purpose of the lab is to restore function in individuals with spinal cord injury.
We are using a unique device, novel device, implanted into the individual, and this device is able to capture signals from the individual's brain.
And actually watch when the brain sends those signals and actually translate them in real time into the actual movements that somebody is trying to make. I think as the technology continues to improve, and it's improving so rapidly, we're going to be able to do more and more complex things, opening the realm of controlling an entire arm, reanimating both upper extremities, or even getting somebody to ambulate.
Ultimately, it would be great to see somebody with a spinal cord injury and quadriplegia be able to walk, be able to, drive, be able to do the things that they commonly can't do on a daily basis.
And having the ability to do all of those things from a single implant, I think that's very exciting.
It's something that I think is unique. I think the way we're going about it is unique. I think that just brings a level of excitement. I mean, I think the future is bright, and I think that we're going to ultimately be able to restore function to people in a very meaningful way.
We're also harnessing the power of the brain to break the cycle of opioid addiction, targeting new therapies to prevent relapses in drug abuse to keep patients healthy.
I first got into studying drug addiction when I was in graduate school. We focused on not just drug abuse, but the insulin system and how we can repurpose type 2 diabetes drugs to lower intake of nicotine. The potential of being able to expand the label of a drug, of a therapeutic, to help millions of people that are currently struggling with smoking addiction was a big motivator to continue in the field and to expand my research. What our lab is focusing on is looking at microglia, the resident immune cell of the brain, that can be hijacked by opioids to drive craving and relapse, and ask the question, can we take it back? Can we take back these microglia and restore them to a place where we can control the craving and prevent relapse in opioid abuse? If successful, we'll have uncorked this new family of potential therapeutics for drug addiction, not just for opioid abuse or opioid addiction, but for other drugs as well. We've only scratched the tip of the iceberg when it comes to understanding the role of microglia in addiction. For us, that's very exciting. There's a lot more to find out. We feel like we're on the cusp of something special, of making a big discovery. That's the best way you can feel in science, always to be so close to making a discovery. That's what drives you.
The human brain is vast and powerful, but so is our commitment to finding novel and effective treatments in the neuroscience. We are continually pursuing cutting-edge ideas that will improve the health of humanity and the quality of life for so many of us. We look forward to partnering with you to continue developing this revolutionary and life-changing medical technology.